Hey everybody. So we're getting into 7.2 today using isosceles and equilateral triangles. All right, this first slide kind of explains what those two types of triangles are. So go ahead and get the title, get the slide, and I'll dig into it. Okay, so the first type of triangle we're looking at here is what's called an isosceles triangle. All right, there's kind of a lot here, but the main thing I want to point out is what makes this triangle isosceles is that it has two congruent sides. Okay, this side length here is congruent to this side length here. Okay, so that is what makes it isosceles, having just two congruent sides. Okay, the rest of this stuff is just, I guess, vocab that you'll see throughout this lesson and lessons in the future. I guess the first things I want to point out are right here, the names of the angles of an isosceles triangle. We call these two angles on the bottom here the base angles. All right. The easiest way to identify the base angles is that they are opposite the two congruent legs. So this would be a base angle and this would be a base angle. I know there's a lot of arrows here. That's why I didn't put those, but we'll look into that more on the next slide. Okay, so those are the base angles. This angle up here that's not a base angle is called the vertex angle. Okay, you might see that ever so often, just so you know. Okay, and when it comes to the names of the sides of an isosceles triangle, the two congruent sides are just called the legs of an isosceles triangle, kind of just like when we had a right triangle, if you guys remember. We call these two side lengths here and here the legs, and this was considered the hypotenuse. Okay, it's the same idea here. These are considered the legs, though the other side of an isosceles triangle is called the base of it. All right, and the easiest way to think about the base is it's the same side length that touches the two base angles. Okay, but really the big thing to take away from this is just isosceles triangle has two congruent sides. Okay, when it comes to the idea of an equilateral triangle, that is just when we have three congruent sides. All three sides of a triangle are congruent for it to be considered equilateral, which kind of makes sense. You can hear it in the name. Equilateral literally just means like equal lengths. Okay, all three sides length equal. Okay, so yeah, those are our two big triangles here. So the first thing we're going to look at is what's called the isosceles base angle theorem. Go ahead and copy this and I'll show you what's going on. Okay, so this is a pretty simple theorem. Here's what it says. If two sides of a triangle are congruent, or in other words, if we have an isosceles triangle, then the angles opposite them are congruent. All right, so over here, here's our isosceles triangle. We have two congruent side lengths. This theorem says that if these side lengths are congruent, then the angles opposite these two side lengths, this angle here and this angle here, are also congruent. Okay, which by the way, those are the base angles. Okay, so if we got congruent sides, we have congruent base angles. Okay, the other thing I want to point out is that the converse is also true. What that means is that if we have two congruent base angles, then the side lengths opposite those angles are congruent. Okay, so just to sum it up, congruent sides leads to congruent base angles, and congruent base angles leads to congruent sides. Okay. Okay, so with that idea, I don't need you to copy this problem. I just want you to take a look at it and see if you can figure out what it's asking. Here's what it says. Find the measure of angle E and then the measure of angle D. Okay, so take a look at this. If the measure of angle F here is 80 degrees, what does the measure of angle E have to be? Take a guess. Okay, well, here's what we know. This is an isosceles triangle. Since these two side lengths are congruent, that last theorem we looked at tells us that the angles opposite these side lengths are also congruent. So if this thing's 80 degrees, I know this thing's 80 degrees. Okay. Next question. If we now know these two angles, can we use them to find angle D? This angle right here. Okay, well, if you guys remember, the three angles of any triangle always add to 180 degrees, right? So if this is 80 and this is 80, that would be 160 degrees. So that means angle D would have to be what? 20 degrees. Okay, so you can see we're still using the stuff that we learned in the past, but we're just adding more and more things. Now we're looking at particular types of triangles. Okay, So let's now try an example that is throwing in some variables, requiring us to, make some equations out of what we just learned. So go ahead and copy this. We'll try it together. Okay, so here is what I notice on this problem. We have congruent base angles. Okay, so here's what we know. Since these angles are congruent, this is, by the way, this is using the converse of that theorem we were looking at. We know the side lengths opposite these base angles are also congruent. Okay, so this side length is congruent to this side length. And by the way, draw these arrows in your notes and then show yourself that these side lengths are congruent. That's what it's all about. Okay, so to find x, we can just make an equation out of this. We know that this side length is equal to this side length. We can literally write them equal. One thing I want to point out, this fact that this side length is 16 is just extra unnecessary information. Sometimes they're going to give you more information than you need to be able to make, solve your equation. So sometimes you need to ignore some stuff. Okay, so yeah, these side lengths are congruent. So let's go ahead and say that 5x plus 5 is equal to 35. Okay, and now we have a really easy equation, right? We can subtract this 5 from both sides. Right, and we get 5x equals 30. Divide 5 into both sides, and it looks like x is going to equal 6. Okay, so really easy math. This is math we've done all the time. We've been setting things equal a lot. It was just knowing that these side lengths were equal because they were opposite these congruent angles. All right, so let's look at another one here. This one's asking us to find the measure of angle P. Again, go ahead and copy this. We'll try this example together. Okay, so this one's a little weirder. Let's break down what's going on here. First thing I notice, we have congruent side lengths. We have an isosceles triangle. Okay, so here's what we know from the theorem that we learned at the beginning. We know that the angles opposite these two congruent sides are also congruent. Okay, so we can say that this angle is congruent to this angle. Okay, well, how does that help me? I don't know what angle P is. If I did say they said this thing was 60 degrees, I could just set these equal and I could solve. But I don't know what the measure of this angle is. Okay, but they are giving me this angle up here, which by the way is called the vertex angle. Okay, so what can we do with this? All right, well, here's what we know. We know that since this angle is called a 3x plus 3, and this one is congruent to it, we could also call it 3x plus 3. Okay, let's go ahead and do it. Okay, right? They're the same. We can give them the same names. Okay, here's what we have. We have a value for all three angles of this triangle, and we know that the three angles of a triangle add up to 180 degrees. So we can make an equation out of this. We can say this angle plus this angle plus this angle equals 180. Okay, let's go ahead and do it. So 3x plus 3, this angle, plus this angle, another 3x plus 3, plus this angle, 5x minus 2. Notice when I'm making my equation, I'm not using the parentheses or the degree symbols. We know those three angles add up to 180 degrees. Okay, that is the hard part, is kind of realizing that. Okay, so this is still, again, using information that we learned in the past. It's just kind of requiring a little bit more out of us. Okay, so let's go ahead and simplify the left side of this equation. We got some like terms here. So let's add our x's together. 3x and a 3x and a 5x gives me 11x. Okay, 3 plus 3 is 6. 6 minus 2 gives me a positive 4. Okay, over on the right, we have 180. Okay, now we can subtract this 4 from 180. So we get 11x equals 176. And then we're going to get rid of 11. It's being multiplied, so we're going to divide. And x is going to go, x is going to be isolated, and 176 divided by 11. I'm going to do this on my calculator. It actually goes evenly, and we get 16. Okay, one thing I just want to point out, we won't always get nice, clean numbers. Sometimes you're going to get decimals when you solve for x, or sometimes you're going to get a negative number when you solve for x. If that happens, though, double check, because especially on like a test, I will often give you problems that are nice and clean, though it's possible you might get a decimal. I just want to point that out. Okay, here's the big thing. Did we answer their question? Did they say find x like they did on the last problem? No. They're asking us to find the measure of angle P. So we're not done. This is part of our answer. I like to underline it, okay, but it's not our answer. We need to find angle P. Okay, so now that we know what x is, though, we can plug it back into angle P, the 3x plus 3, and we can get our answer. Okay, so let's go one more step. I'm going to take 3x plus 3. I'm going to plug in my 16, so 3 times 16 plus 3. Okay, and by the way, we should probably say angle P equals. I'm getting a little lazy here. Okay, but yeah, let's see. 3 times 16 is 48, and 48 plus 3 gives me 51. So angle P equals 51 degrees. Okay, that's the answer they're asking for. Okay, some quick questions. What if they had asked us now for the rest of the angles? Well, we'd be able to get them really quick, right? If angle P is 51 degrees, we know angle Q is 51 degrees. 51 plus 51 is 102. These should add to 180. So if those add to 102, this thing would be a 78-degree angle. Okay, they didn't ask for those, but just remember, if they did, we can find them really quickly. I didn't even need to plug in x into these other ones, though I could have, and I would have gotten the same answers, but it was unnecessary. Okay, so it's just stuff I want to remind you of. Okay, I'm going to have you guys try one of these out on your own. This one's just asking you to solve for x. Okay, so go ahead and make an equation out of this information. Okay, just remember, these congruent sides right here mean that the angles opposite these sides are also congruent. Okay, we don't know what angle S is, but we can give it a name, just like we did on the last example, and we can make an equation out of what these three angles add up to. Okay, I'm giving you some vague hints, so go ahead and try it out. Make your equation. Okay, so this one's a little tricky, but the first thing to realize, since these angles here and here are congruent, okay, by the way, if I knew what angle S was, I could get my answer. Say they said it was 40 degrees, I would say x equals 40 degrees. I'd be done. But we don't know what it is, okay? But we do know that since this one's called x, we can also call this one x. Okay, now we have a name for all three angles. Now we can make our equation. We can say that x plus 3x, those three angles added together equals 180 degrees. Okay, and now combining my like terms, x plus 3x gives me a 5x equals 180. Divide 5 from both sides, and it looks like we're going to get x equals 36. Okay, and that's it. They just asked for x. Though just remember, if we needed to find the measures of the actual angles, it'd be really easy. Angle R is 36, angle S is 36, and angle T is just whatever 3 times 36 is. Okay, but didn't ask for it. Okay, we have one other part to this lesson. The next thing we're going to look at is, equilateral triangles and the equilateral triangle theorem. So go ahead and get this slide here and I'll explain what's going on. Okay, so this theorem here is a lot like the other theorem we looked at when we had congruent sides, which led to opposite congruent angles. This is almost the exact same thing, just in the context of equilateral triangles. Okay, so here's what it says. If a triangle is equilateral, meaning if we have a triangle with 3 congruent sides, then it is also equiangular. Okay, and equiangular is exactly what it sounds like, meaning all 3 angles are equal. Okay, so if all 3 sides are congruent, all 3 angles are congruent. Okay, and the converse is also true. If we had a problem that had 3 congruent angles, we would know that that meant it also had 3 congruent sides. Okay, and just so you guys know, technically this is using the same logic as that other theorem. It technically means that if we have congruent angles, that if we have congruent sides, that the angles opposite these sides are also congruent. Okay, it's almost using the exact same idea as that other theorem, just so you know. Okay, but don't overcomplicate it. If you have congruent sides, you have congruent angles, and vice versa. Okay, so with that, I'm gonna have you guys try one of these out. Okay, this one's asking us to find segment DE. Okay, so this segment right here is what we're asked to find. Okay, let's make some sense out of this, and I'm gonna have you guys make your equation and solve for x, and then plug it back in. Here's what we have: a triangle with 3 congruent angles. Okay, well here's what we know: if we have 3 congruent angles, that means we also have 3 congruent sides. okay? And now we can make our equation. We know that these side lengths with our variables in them are equal. So go ahead, set them equal, solve for x. After you solve for x, plug it back into sorry, I should have caught this. We're not plugging it back into df, we're plugging it back into de. We're looking for de, this one right here. Okay, but really, it's the same idea. After you find x, to find de, we're actually going to have to plug it back into one of these other two sides and figure out what they are, and then we'll know what de is. Okay, so a lot of explanation here. At the very least, go ahead and make your equation and solve for x, and then try to figure out what de is. Give it a try. Okay, so we figured out that these side lengths are congruent. Let's go ahead and set them equal. 5x minus 12 equals 3x minus 4. Okay, one thing I want to point out, guys, when we're talking about side lengths, I see this every year. Sometimes students will see side lengths and they'll go, oh, they add up to 180. No, remember, side lengths do not add up to 180. It's the angles of a triangle that add up to 180. Okay, so just be careful of that. Okay, so the side lengths are congruent, set them equal. From here, we got variables on both sides. Remember, you can bring them to the left or the right. I'm going to subtract the 3x over to the left. So this is going to give me a 2x, bring down the minus 12, get a minus 4 on the right. Now I can solve for x here, add 12 to both sides. 2x equals, remember, negative 4 plus 12 is the same thing as 12 minus 4. We're getting 8. Divide 2 into both sides. Looks like x equals 4. If they were asking for x, we'd be done, but we're not. Okay, but that's going to lead us to our answer. Okay, we don't have any value, anything to plug in for DE, but we know if we plug it into either one of these other sides, we'll figure out that length, and they're all congruent. They'll be all the same length. Okay, you can plug it into either one of these. I'm actually going to choose to plug it into this one because I like the numbers. They're a little bit smaller. Okay, so I'm going to plug it into the 3x minus 4. Okay, and I'm going to plug in 4 for x. So 3 times 4 minus 4. 3 times 4 is 12. 12 minus 4 is 8. Okay, so I know that this side is 8, and that means that this side is 8. Okay, and by the way, that also means this side is 8. Okay, but there's my my answer here. DE, segment DE equals 8. Okay, by the way, normally we put units like 8 inches or whatever, but there are no units here, so we'll just leave it as a generic 8. Okay, so there is our answer. Okay, so yeah, guys, not really anything too crazy, just, more setting things equal, more adding the angles of a triangle up to 180. It's just understanding it in the context of these two new triangles. Okay, so hopefully you're feeling good on this. I'll see you guys in class. Bye.